In this video, I'm going to take 5 random models from Thingiverse and try to 3D print them successfully. And when I say random, I really do mean random. Welcome to the 3D printing gauntlet. Let's get started. How's it going, guys? Angus here from Maker's Muse. I recently promised a video showing my process for slicing models for 3D printing, and I thought what better way to show it than to get 5 completely random 3D printing models of the internet on Thingiverse and then try to 3D print them. Thingiverse has been around for a very long time, and it's the largest repository of 3D printable models anywhere on the internet. Now, that doesn't mean that the models are all good or if they even can be 3D printed, but it is by far the largest. You can see here in the newest tab, the most recent one was only 3 minutes ago. But I want to choose 5 completely random models. And if you go to random, well, it's not really random, is it? It's still models from 16 hours or so ago. I don't think they ever actually made this feature work. So what I thought I could do is take advantage of the fact that every model on Thingiverse has a thing number. So let's fire up a random number generator and let's find out how many things there is on Thingiverse and choose something in between. And as you can see here with this most recently uploaded model, it has a thing number of 3,684,882. Wow. That's a lot of things. So let's copy that number over to my random number generator. But before we begin, a few rules. I will not 3D print anything that's weapon related. It has to be 3D printable, so no models designed for laser cutting or anything like that. And if I get a 404, I'll just keep going till I have 5 models that I can try to 3D print. So let's kick it off with the first one. That's actually pretty close to the most recent things. I wonder if it actually comes up with anything. Okay, we have our first item, and it's an IKEA Tradfri remote and dimmer adapter for a Gira Standard 55, whatever the heck that is. The cool thing about 3D printing is you can make very specific things for your use case. This is obviously a very niche use, but it looks like a very simple model, so we're off to a fairly good start. And it's going to be quite simple to show you how to slice. Okay, I've downloaded that model. Let's find our second. We've got 2470119. Still in the millions, which is actually interesting. Let's put that in there. See what it comes up with. 404. So this isn't too uncommon. If someone's made a model and never published it, or if they've deleted it, it's 404. That's okay. Let's find another one. 404. 404. 404. Finally, another model. So what we have here is a customized model. So Thingiverse has a lot of customizable models where you can alter them. And this user, Southwest145, has made a customized iPhone case. I'm not sure what iPhone it's for, but we'll download that and I'll show you a good method for printing strong phone cases. Cool, okay, we finally happened on our third object, boosted board style battery case for MEB Stealth battery. So this is a electric skateboard, and they've made a battery case, which actually looks like it might be kind of interesting to 3D print. So this looks simple, but I think it's going to be a little bit interesting to choose the orientation to print this. It looks like I split it in 2 pieces, so it looks like it might be fairly large. This was made by Mk3. Fantastic. Let's download that one. Sweet, okay, we have our 4th model, a keychain bobblehead for Charisma from Fallout 4 by Punch and Bill. And this is going to be an interesting one to try to get the highest detail possible. So not so much a challenging print in terms of support material, though it might have some stuff that I might have to play with, but that's going to be an interesting print as well. And we have our number 5, Marvin the Martian keychain by HTW112. And this is a dual color 3D print. So this is going to give you an example to show people my dual color process using the Prusa Mk3. And we're going to be using the latest PrusaSlicer 2.0 to slice all of these models. So we've got our 5 models. Thankfully, they're all fairly small. I wasn't sure what I was going to get. So let's fire up the PrusaSlicer and I'll show you how I'm going to slice for each of these specific models. Alright, this is PrusaSlicer 2.0 and it's the slicer I'm going to be showing and demoing in this video. It's the latest slicer from Prusa Research and it's based off the original slicer, but now it's fully standalone basically. and it has a lot of cool features. It's very powerful, but also still fairly user-friendly. So let's start with our first very simple model, which was the IKEA remote adapter. So I'm going to grab the models in that folder and bring it across. Okay, so I brought two models across, and they're these two. So I don't know why there is two. It says one is for the dimmer and one is for the remote. So I guess those holes are what makes the difference. But these models are very, very simple. The designer has made sure they import in the right orientation, which is fantastic. But let's just say, for example, if they came in like this or something. So if models come in weird angles, they might have been modeled at different orientations and not arranged for easy slicing. And there's a very easy way to orient this properly with the base flat, and that's using this option over here, which is place on face. So to use it, you just click the model that you want to position flat, and you select place on face, and it will give you the face the options that you want to put it down on the face. So I want to put it this side down, and then down it goes, just like that. And if you're not sure if the model, for example, might look very much like it's close to being flat, but it might not be exact, you can just double check. So these models are very simple. There's no support material needed. There's not going to be a challenge to keep them in place, but we might want to make sure that the first layer is a good fit for the interface, although I can't test it, for the original dimmer. So let's go into our print settings. Print settings here. So I've got it currently on the default, which is 0.15 millimeters per layer, and it's on quality, which means it's going to be a little bit slower than the fast setting built into Slicer. You can change all of this, but this is what I'm going to be starting with most of our models and then tweaking it. So layer height 0.15. For a simple model like this, it doesn't need to be 0.15. It's very blocky. You don't see the layers very easily. It can very much be 0.25. It prints quicker, and it's going to be easier and probably stronger as well. And it's just, you don't need 0.15 with these blocky models at all. 0.2 is fine. Perimeters though, because it is a functional part, we might need more than 2 going around. So in this circumstance, I would actually put it up to 4. So it's going to make it very strong, and it means that it's going to be a better functional part. Top and bottom layers 7 and 5. I don't usually change this, but if we had a model with a curved top, I might need to, but for this, it's perfectly fine. This model is going to be almost solid, but it's so small it doesn't matter. And infill, again, it's going to be almost solid, but I will say the default being gyroid is a little bit silly. I think they just wanted to show off this new slicing infill option, but completely unnecessary for most printing. So I'm just going to put it back down into rectilinear, which is totally fine. You might want to try cubic, but we're not going to do it for this model. You're probably going to have very little infill in this model anyway. Okay, so as I said, this model needs to fit around something, around a dimmer. So what often happens with that first layer of the 3D print is it often bulges out a little bit because we have it nice and close for layer adhesion, which means that you get a decrease in that internal diameter because it's going to actually bulge out a bit and then come in. It's called the elephant's foot of the 3D print, and it's something that we don't really want. So to eliminate elephant's foot on 3D printing, there's actually a setting in Slicer Prusa Edition version 2.0. If we hit Advanced here, we need to turn Advanced on, and then go to Advanced tab, there's actually a slicing option, Elephant Foot Compensation. And we can change elephant foot compensation to compensate for that squish, so we actually get a more accurate first few layers. So I'm going to change it here, and I'm going to make it, let's go 0.4. I think you'd have to play with this, but let's try that. Okay, let's go back to our platter, and let's slice. Sweet. Okay, so this is our model. Sliced, as I said, with 4 perimeters, it's going to be nice and strong. And we can have a look at what the model actually looks like. There's very little infill, if any. Actually, there's no infill, basically. Tiny bits around in our 4 perimeters. But we can see that first layer is just a little bit smaller. And that's going to be really useful for getting that internal diameter to make sure it's not going to be squished out too much and means that the parts won't fit together. So I am pretty happy with this. My filament setting is Prusa PLA, which is a slightly higher temperature than the generic PLA, but it generally means it's going to work with most filaments, most PLAs. So I'm happy with this. It's going to take 1 hour to print, and I'm going to now save it to my SD card. Alright, next we have the customized phone case, which says rock solid creative design. So whoever you are, congratulations, you made it into the video. And this is going to be interesting because printing phone cases, they need to be quite delicate and quite accurate. So I've got a clean slate. I've gotten rid of all my changes from the previous model. So we've got it back down to 0.15mm quality Mk3 default. And we're going to go in and change a few things to make sure we print this case as accurately as possible. So print settings, layers and perimeters, 0.15 will be necessary for this model to get a nice even curve. It does have a slight curve to it in this model, so we do want a fine layer height. 0.15 will be fine. Perimeters though, it's very thin, so 2 perimeters is probably what we need to go with. We don't have room to do really more than 2. It's going to be very thin as it is. And under the advanced settings, we need to tick this, detect thin walls. So what this does, as it says, detect single width walls, parts where 2 extrusions don't fit, and we need to collapse them into a single trace. So this is important where there's very thin details, it will collapse them into just a single extrusion, which means you'll get a little bit more detail out of your 0.4mm nozzle, which I'm assuming you have as default. It's what I'm working with. It comes standard on the Mk3. And just one little trick we can do to get a little bit more detail out of our nozzle going to the advanced tab is our extrusion width. So a 0.4 nozzle usually extrudes, it's set to extrude a little bit further out. So 0.45 here, I'm going to set that to 0.42. It's really splitting hairs, it's not going to change much, but we'll get a tiny bit more detail out of the nozzle because it's not laying down as thick extrusion lines, but it's really is splitting hairs, but it's worth changing. And that's about it. So let's slice this model and see how it looks. Alrighty, so here we go. So see what I mean about the very thin areas? These little bits on the stencil are just 2 extrusions, very, very thin. And the actual case has been well designed, but you can see here, it's actually had to collapse down to single extrusion lines for the lip of that case. Very, very thin. And I haven't changed the speed settings or the layer height settings. It's still the default quality for the Mk3 at 0.15mm layer heights, which I think is very important. And I also don't have the that elephant foot compensation for this because it's not for, there's no dimensional accuracy required. So I want to have it just flat. It might leave a little bit of a lip there, but I'm not too worried about that because we can't really have it anyway when it's doing these really thin details. We don't want it squishing in any more than it already has to. So I'm going to save that as is, and then let's move on to the next one. Okay, so I see what the designer's done. It's so large, they've actually split it into 2 pieces. I thought I escaped printing large stuff in my random choices, but apparently not. And I don't believe the largest one will fit on the Prusa Mk3. Let's have a quick look by laying it flat. Nah, it's too big. Okay, that's fine. So we have these 2 halves here, which I will need to print and then assemble afterwards. And they're very large and chunky, but they have quite a difficult geometry to them, actually. So let me just do one at a time. I'll get rid of this one for now. But see this model, it's curved on most faces. It's got an angle there. It's slightly curved here. And it's got this lip here as well. So what that means is I can't just print it like this because it's going to have an overhang here and an overhang at the top. Now that top overhang, if I try to look at it here, it might bridge, and I'll do some settings, but it might not be that clear. So we're going to need support material for this model, at least for the bottom detail. So let me just slice it to get a good idea of where the plastic's going to end up, to see if I can get away with bridging or not. Bridging, if you're not familiar with, will just go across thin air without support materials. But there is certainly limitations to that. So let's have a look here. See that gyroid infill? Not necessary for this at all. So you can see here, as it starts to go up, it goes more and more over thin air. Like that. Okay, then we do have a very substantial bridge. That's one layer going across. I think we could get away with it, but it's pretty close. So I think we could get away with that. It's close. We're not going to look very pretty, but we can't get away with the overhang down at the bottom. So what we're going to do is take advantage of a new setting in the PrusaSlicer, which is support blockers and enforcers. Okay, so we've determined that we don't want or need support material through the entire print here. We just want it in these little overhang bits there because they really do need it, otherwise the print's going to fail. And we can do that in PrusaSlicer using support enforcers. It's very easy to put them in now. So let me just show you. Right click on the model, right click, add support enforcer, and then box will do us. And luckily the box is like exactly the right size. So we can just chuck that in, make sure it's covering our areas. Do copy paste, CV, Control C, Control V, chuck another one in here. Looks good to me. Yep. Okay. And then we need to go into the settings menu. So back to print settings, and you need to have generate support material ticked, but you need to untick auto generated supports, which means that it's only going to generate supports within those support enforcers. And then slice. And there you go. So now we just have support material down here in those areas that we really need it. And then everything else, like the holes up top and all that, will not have supports. And we can actually, hopefully, save and cut down a lot of material and time. So I'm going to now export this and save it off. Okay, next we have our Fallout Bobblehead Charisma. There's 2 models in the pack. And one of them has built-in supports. So this is clearly designed for a resin 3D printer. These are tree-style supports, and they don't work on FDM machines, at least in my experience. We're not going to be able to print it like this. So I'm going to delete that and pull in this model. And this is the one we're going to be printing on the Prusa Mk3. It's a very small, challenging model, so very high detail. So in this circumstance, we actually might go to the 0.1 Ultra quality. Get rid of that. Yeah, it's fine. So this is 0.1 detail. I don't go to the 0.05. That's ridiculous. This will be fine, but we need to change its orientation to be more vertical, I feel. So we can add some supports in, but make it more suitable for FDM 3D printing. So to do that, I'm going to choose my place on face, and I should be able to place it vertically, hopefully, or at least close to vertical. I mean, that's pretty good. That's fine, I think. Okay, so there will be some support materials required for this model. So I'm going to try the auto generation, but also I'm going to give it a raft. So I like to use rafts when there's very delicate models with supports going all over the place, because supports straight onto the bed often fail. In my experience, they often break free. So under the print settings, I'm going to go down to the support material tab, generate support material, yes, and raft layers. I'm going to give it, give it 2 raft layers. Let's give it 3 raft layers. Okay, that looks fine. And let's go back to our platter and see what it creates. Okay, it looks like a lot of support material because it's vertical. If you put it this flat, there would be a lot less support material, but the detail won't be there. You get much higher detail with FDM in the vertical versus the horizontal. Because remember, it's still a 0.4mm nozzle, but we're printing now at 0.1mm layer height. So that's a 4 times detail increase that we're able to achieve. Looking through this model, it looks like it might have some errors in it. And you can see also there's a little warning symbol here saying auto repaired. Right button click the icon to fix STL through netfabb. Let's just try that. That's a new feature. I haven't even seen that. That's pretty cool. So how cool is that? It has a built-in netfabb repair in PrusaSlicer 2.0. That's freaking fantastic. So before I slice it again, I'm actually going to change from gyroid infill. Again, I don't really think that's necessary. So let's go from there to rectilinear. And the layers, I'm going to change that to 3 again. So I like having 3 perimeters in my models. Let's slice that, and it should definitely slice a lot cleaner now. So a lot of support material again, but keep in mind this stuff will break away quite easily. And because we're printing vertical, it does require it, and that's looking a lot cleaner. We've got a little bit of that infill stuff, a little bit of that there supporting the layers above it. That's fine, but that looks pretty darn good. You can see why we had that raft, because we need that nice area for the support material to form. And also the contact points of the model is very small. Yeah. But I think that's going to print good. I'm really confident that's going to print quite nicely, and you can do high detail on an FDM machine if you have the right printing settings. So I'm going to save this one off. Alright, we're on to our final model from Thingiverse, Marvin the Martian, and this is a dual color model, so it's got a backing and it's got the model on top. So I've just brought everything in from the files. So what they've done is they've got two split ones, and they've got one that's all combined. So I'm going to delete the split ones because we don't actually need that in the PrusaSlicer. So what I'm going to do is go back into my settings, 0.15 millimeters quality Mk3, and again I'm going to turn back on that detect thin walls option, which you need to have the advanced tab on to see, and then that way we can get a little bit more detail. And again I'm going to change my the extrusion width down to 0.42. Gives a little bit more detail. It's debatable. Alright, that took quite a while to slice, and I can see why. So all of these lines are single perimeter, single width, line width, and it's going to be really delicate. And I don't think it's going to print all that great, to be honest. Especially these bits here and here. I'm not confident. So I'm actually going to change something to make it artificially inflate them. So this would normally mess with your dimensions. But in this circumstance, I think we need it to give the model more strength and more actually resolve better detail. And to access that magical setting, we actually need to go into expert mode. So simple, advanced, expert, and we need to go down to advanced. Now what we're looking for is XY size compensation. And what this is going to do is artificially inflate all of the faces of the model by a certain amount. And we want this to make the model actually stronger and have more than just one single perimeter, one line, and actually give us more definition when we add a second color. So to do that, I'm going to do a 0.4. And I think that will look good, but let's see what the G-code slice preview looks like. And that looks so much better than before. We've got some nice thick lines with, in some cases, 3 perimeters. It's going to be a lot better in terms of the definition compared to what it was before. It's going to be much, much clearer. Sweet. Okay, so we've got the model. It's going to look good, but we need to add a second color to make it really, really pop. And you don't need a dual extrusion 3D printer to do it. You can actually just tell the slicer when you want to change color, and it'll send a special G-code across to make the machine pause and then wait for you to change filament. And telling your 3D printer to pause and change filament is actually stupidly easy using PrusaSlicer. So you can see here in our G-code preview window, we can slide down to see the actual model as it's being formed. We can actually just go to the point where we want it to change color. So that would be one color. Then this is the first layer of the second color, and we just click this plus. Simple as that. We now have a visual identifier to show us the different color, and as we slide up, you can see that we're going to have 2 colors, and it's going to make the Marvin really, really pop. It's going to be nice and thick, so we're at 0.15, happy with that, and now I'm going to export this, and this is the last model now, so you'll see me next down at the 3D printer, and I'll explain how it all goes together. Alrighty, so how did we do? Well, I kicked things off with the IKEA dimmer adapter thing, and it printed out as you would expect pretty much perfectly. The extra perimeters gives it lots of strength, and it actually doesn't need too much infill, so I actually think this one had no infill really, it's pretty much solid plastic. And the elephant foot compensation did work okay, but it turns out my first layer was just really quite close on my Prusa Mk3, to be safer than sorry. And there is still a tiny bulge there. Not as bad as it would have been if the elephant foot compensation wasn't used, but I think with this setting, I would like to see it be able to be used for more than the first layer. Maybe the first 2 or 3 layers, you can compensate by a little bit. Or if you're the designer, do what I do and just put a small chamfer at the bottom of the part to give it room for that extra squish, which you really generally do need for that first layer adhesion. But yeah, as expected, these parts printed out pretty much perfectly. Next was a phone case, and you'll remember we made a few tweaks to our slicing profile and settings to get the best detail we could on that text at the bottom, that stencil style text, and it actually printed better than I expected. It's fully readable, there's no real issues at all, and the edges of the case are nice and clean, and I think this would work, but I don't have the type of iPhone this is designed for, so I can't test it, but it looks clean, and as long as the designer did a good job with the CAD model, I think it would work perfectly. The Fallout 4 figurine was the most detailed model we tried to print, and I printed this standing upright with support material enabled, and we did a few tweaks to the slicing settings to try to get the detail out of it, and it actually printed, again, better than my expectations, but it's not fantastic. Printing this with a 0.4mm nozzle really does start to show the limitations of this technology, and although the front and the back looks pretty good, it's a little bit rough and the bottom looks very rough. But having that raft really did make a difference to keeping the support structures stuck down, and I think if you're in a pinch and you only had this technology to print something this small, you definitely could do it with that 0.1mm layer height setting and the small tweaks that we did. In the end, I only printed one half of the battery holder for the electric longboard, and this print failed, actually. I came back to a big pile of plastic, and I wasn't exactly sure why, but then I realized that we didn't actually have much bed adhesion, and it's been very cold. It's pretty much the heart of winter here in Australia. Although we don't get negative degrees, the workshop definitely gets cold at night, and I think it just wasn't enough bed adhesion. And you can actually see where the nozzles caught on the part and popped it free and then just printed in midair with this part broken off. So what I ended up doing is going back into the slicer and adding a brim. Now a brim gives you extra bed adhesion and you just have to break it away afterwards. It's only used in the first layer, and I added an 8mm brim around the whole part because it is very thin and this is only one layer thick, so it just peels away afterwards. But you do need to remove it, and it made a substantial difference. I also took this opportunity to move my support enforcers down a bit so that first hole wasn't being filled with support, which I did mention in the slicing settings, you don't need that. So this is the next attempt. I did run out of the blue filament at this point, so I used an orange, and the part stuck down perfectly, printed really well until it got to that bridge, and that bridge is super messy. The top surface did recover, and if you didn't have to see it, it wouldn't really matter. But the reason it's so messy is because it's not a perfect straight line, it's actually a curve. And for a bridge to work correctly, it has to be across just a straight gap. And even if this was a straight gap, it's probably at the limit of a distance that a bridge would work. So we were really pushing it here. Unfortunately, this model might need support material all the way to the top, unless the designer added in some built-in supports that could be broken away, perhaps coming at a 45-degree angle from inside the part. But yeah, it's pretty rough, but if you remove that and then put it into place, you wouldn't even see it, which might be totally fine for this application. And this was printed at 0.3mm layer heights. I actually ended up making a new profile because I didn't save the previous one. So 0.3mm layer heights is fantastic for large functional parts, and as you can see, it really does look quite good. You don't have to go any finer for parts like this. And then finally we have this dual color Marvin the Martian. I decided to do a black PLA for the first layer and then change over to a gold polyalchemy elixir PLA to make it really pop. And this printed super good. So the M600 command is usable on most 3D printers with Marlin firmware. You just need to make sure that it's actually in the firmware that you've got flashed to your device. But on the Prusa, for example, the machine beeps and pauses and waits for you to come, and it's got a whole routine to withdraw the filament and load new filament in when it gets to that layer. The one thing about color change is it does ooze a bit while it waits to warm up again and goes back to its original point. So when I was doing this, it did dump a really nasty bit of ooze in the top corner of the keychain, and I had to pause again to cut that free. So that's not ideal. On a big model you wouldn't notice, but this one's so finely detailed that I really had to intervene to get rid of it. And there is a little bit of stringing because it was just jumping all over the shop to do tiny little details, but it wasn't as bad as it would have been if we didn't thicken up the model using that XY offset. That really is a magic feature to add detail to parts that are just a bit too thin to print. And again, it's going to mess with your dimensional accuracy, but if that doesn't matter, then you can really get some parts to pop. So I'm really, really happy with this result. I don't do dual color 3D prints very often on this channel, as you guys might know, but I might do it more often considering how well this came out. So there you have it, 5 completely random models on Thingiverse and my process for slicing them for 3D printing using PrusaSlicer 2.0. I truly do hope you found this video informative on some of the features that are hidden away in slicers that you can use on a part-by-part basis to get the best 3D printing result possible for your project. And if you did enjoy this video, maybe consider subscribing to Maker's Muse, because it's my aim here to empower your creativity through technology. But till next time, I look forward to seeing you again very shortly. Catch you later, guys. Bye.